leading this program. Great to have this crowd here. I can see many familiar faces, and I'm pretty sure that with this group and 5 years, we can transform the world together with carbon nanotubes. I'll start with some 15 minutes intro, and after that we will split into 3 workshops for some ideation together, and then we will summarize after the coffee break. I think the ideation part will be a lot of fun, don't worry, it will be a low threshold one, but great to have you all here. Maybe I'll just start. So firstly, what is Carbon Age? I think Carbon Age is 2 things. Firstly, it's a vision. Secondly, it's a Business Finland funded program. I'll come back to the program part a bit later, but firstly, the vision is that change is inevitable, and there are legacy materials like silicon that are reaching their limits, and that's hindering technological progress. Superior performance is needed, and advanced carbon nanotubes is what is going to solve those problems. New wave of applications is going to come, and even market reports independent of Canatu are proving that advanced nanocarbons are growing very rapidly in many domains. One concrete example of those new applications is here, the ASML's roadmap for extreme ultraviolet lithography. As you can see, the scanner power is increasing, and to meet the demands of making world's most advanced chips and narrower and narrower line widths in the logic chips, they have to use pellicles, and the legacy material, the silicon-based composite material for pellicle, which is the part protecting the photomask in advanced lithography, will not work in the future and next generation scanners. So their CNT and Canatu's CNT particularly is, I would say, only known working material in that particular application. Another concrete application is here. This is a publicly available TSMC's technology roadmap. As we all know, the Moore's law is not going to continue forever, and there are different device architectures based on legacy materials, again, silicon-based. And as you can see, CNT-based transistor is named as one candidate in future architecture for logic chips. And why carbon nanotubes are transforming industries? That's because the carbon nanotube is an extraordinary material with really super properties. As we go to the nanoscale, the properties really go to extremities. For example, it's 100 times stronger than steel in terms of tensile strength. It's half as dense as aluminum as material. It's electrically very interesting because one carbon nanotube can act as nearly ballistic electrical conductor, or if it's made in another way, it can be a better semiconductor than silicon-based semiconductors. Also thermally, it conducts heat very, very well, and it can take very, very high temperatures without breaking. Just to name a few example properties. What makes Canatu so special in terms of carbon nanotubes is this. We can manufacture advanced carbon nanotubes in an industrial scale. Our advanced carbon nanotubes enable better performance and better properties for the end applications than others. And that's thanks to the dry deposition process, the floating catalyst CVD process that Canatu has developed. And that's something where we can tune and customize the CNT properties to meet the application needs. This is not easy at all. We have spent over 20 years and over 80 million of development money to master this process. But this is where we are now, and now we are here to offer you guys also access to this IP and the knowledge and the CNT material. Going a bit deeper, Juha always mentions advanced carbon nanotubes. What does it mean actually in practice? There are some things that we can tune as the properties of the CNT film. Here are some, let's say, example levers that we can pull to change the properties of the film. Firstly, as I mentioned, we are making the CNT with floating catalyst CVD. As it comes out from our reactor, it still has the floating catalyst material in there, and we can post-process the CNT network, and by removing the catalyst, we can improve the purity and we can improve the optical transparency of the end film. Secondly, we can impact the network morphology. The aerosol CNT fibers tend to bundle, stick to each other, and we can impact how much do they bundle. And by having larger bundles in the end network, we can make very, very mechanically strong films that are tolerant to harsh chemicals, and it also impacts how the network filters particles and how it scatters optical light. Third level is orientation. So we can make randomly oriented CNT films, but we can also make aligned or anisotropically aligned CNT networks, which will then increase electrical conductivity and thermal conductivity and mechanical strength along the oriented direction of the film. This is very beneficial in some applications. We can impact how many walls there are in the CNT. One carbon nanotube is this kind of, you can imagine a graphite sheet that is rolled into a tube, and there's multiple walls in some carbon nanotubes. And we prefer to use the single wall carbon nanotubes for sensing applications because that provides the largest surface area and the most reactive film for the electrochemical sensing. Whereas we prefer to use multi-wall carbon nanotubes where really even more extremely durable films are required. Then we can coat the CNTs. We have learned to coat CNTs with different processes, including ALD and others. And of course, depending on what we coat the CNT with, it affects the properties. And finally, we can functionalize the CNT film. For example, we can introduce doping to increase the electrical conductivity. We can introduce the nucleation points for coating, and we can introduce this biorecognition element or click chemistry to produce electrochemical sensing capability with our sensors. This is really at the heart of what Canatu does. Over the years, Canatu has been working with this CNT core technology and the IP around it, how to manufacture on an industrial scale and how to tune the properties of the CNT. We have also, let's say, productized different platforms around the CNT technology. We have learned to make transparent conductive films. We have applied those in 3D touch sensors. We are applying, as you heard from the Denso presentation this morning, in transparent heaters. We have learned to do freestanding CNT membranes, as you heard from Juha, on the pellicle application, and we are manufacturing those also in other applications. You can see the demos actually in the booth in the coffee area. Then a new topic that we're developing is the CNT biosensors for medical diagnostic use, but we are also looking at other application domains or verticals where to apply that capability. And then let's say a new idea that we're thinking especially under this Carbon Age program is that we want to put CNT on wafers. We want to microfabricate structures out of it and make different devices, whether it's a MEMS device or other micro nanoscale device. That's something we're very interested in. And of course, we are open to also new areas. And Canatu is operating on the CNT and the platform level, and we are kind of expecting you guys to work with us either here, but especially on the product level and together in the ecosystem. We really want to find those applications where we can together provide extraordinary value. So as we heard in the panel, it's very important to have the export potential, the actual business potential there. Otherwise, it's just inventions and not innovation. To a little bit conclude the vision part of the Carbon Age, I could state that Canatu CNT is the ideal building block for high-performing and less energy-consuming products. And moving to the super concrete part of this Carbon-Age is also a veterinary program. That means that Canatu is the leading company, the veterinary company for this program, and we were awarded with the 10 million grant from Business Finland. During this program, it's a 5-year program, we have up to 20 million available funding for our partners, and we are targeting a couple of dozens of partners during this program. What we're actually primarily doing under the program is co-innovation projects. And what are co-innovation projects? Most of you know already, and you can read all about it from the Business Finland's website. But in a nutshell, the primary objective of this project is to generate new export potential, new export business, and promote the competitiveness of the parties. What we're actually doing in those projects is joint R&D. That's going to be done by companies and research organizations, and we want to set ambitious goals, but such that we actually have the capabilities to reach those goals. And we are a small company, as we also heard from the panel, that companies in general, and especially us, need to focus on strategically important few topics. And that's why we are investing in some angles, but under this program we would also like to little bit opportunistically leverage other ideas. And we very much welcome research partners to join the program, and we value their R&D contribution, but we also would like, or our wish is to have the leverage in the coordination role, because Canatu as a small company cannot be coordinating dozens of projects. When we have a research partner involved, there's certain criteria applying to that, so we have to get a bit more companies involved, but still it's very much wanted to have the research parties in the projects. One more idea that we want to include in this Carbon-Age program is this. We want to make pilot capabilities, CNT material library, design and manufacturing rules, kind of make CNT available for different partners to use our technology. And the idea is at this point to maybe leverage the Quantinova ecosystem in this sense, but happy to elaborate and discuss this further as well. But the idea is to have our technology available for partners to then concept to prototype to test and validate and create higher performing products. And I'll conclude with this slide. These are the focus themes you found on the Carbon-Age website and when signing up as well. So we will be focusing particularly under this program on microsystems, so different integrated designs, different integrated devices on wafers, and whether that's a supercapacitor or MEMS sensor or logic chip, that's something we're going to then next ideate in the workshop setting. I'll be leading the microsystems workshop. We will be remaining in this room. The second focus area is electrochemical sensing. We are already developing it for diagnostic applications, but we want to also explore where else could we apply this technology. And Ahmed, who is standing at the door, will take that group, and they will be the next door here. And then finally, emerging frontiers. Ilkka will take the emerging frontiers workshop. That's where we're looking really kind of long into the future and really high potential future technologies and where CNT could actually add value there. Ilkka will take the group, and they unfortunately have to walk close to the auditorium and past it for that workshop. Okay, maybe I'll conclude with this. So we'll start ideating a little bit next in the small groups and some discussion. Canatu will collect the ideas and use them for further refining the program and the idea. So please talk on a level you're confident with.